Hi everyone, thanks for participating in the event hosted by AOCS Student Common Interest Group.
It's not work, it's but learning.
So for the participants, can you make sure that you are muted all the time? Thank you. Yeah, so please update your, if you haven't done so, please update your Zoom file name to your first name and university name. And the event is being recorded. So yeah, so probably you are already being asked when the recording started. Yeah, and a little bit about myself. My name is Dajun Yu. I'm currently a PhD candidate in the Department of Food Science and Technology at Virginia Tech. And my research focuses on analytical chemistry, protein and fiber extraction, and characterization. I will be moderating today's event together with Kevin. And Kevin, can you unmute and introduce yourself first?
Okay. You can hear me, right?
Yeah, I can hear you. I will mute myself.
Okay. Thank you. Hello, everyone. Welcome to today's Student Common Interest Common Group Mixer. My name is Kevin San, and I am a PhD student in University of Saskatchewan at the Department of Food and Bioproduct Science. And for my research is mainly on the characterization of the long-chain polyunsaturated fatty acid biosynthesis pathway. And today's event, Dajun will be as a host, and I will do the moderator during the event. So nice to meet you all, and I hope you enjoy today's mixer. Yeah, Dajun, you can go ahead.
Thank you, Kevin. Okay, so today we are lucky to have Dr. Ragaert to give us a talk on the future of food packaging. Dr. Ragaert is a professor working on food packaging technology at the Department of Food Technology, Safety and Health at Gent University. His research focuses on bioplastics, active and intelligent packaging, and bio materials. One of the key elements in his research is relating different compositions and the functionalization of packaging materials with resulting shelf life of food products. Furthermore, he is leading an organization called Pack4Food together with Anne Vermeulen. Pack4Food is an organization serving as a collaboration platform between packaging industries, research institutes, and other stakeholders in food packaging. It aims to stimulate the innovation in food packaging. And in the last years, its focus has been shifting to packaging materials in a circular economy. So the presentation from Dr. Ragaert will last for 30 to 35 minutes. Then we will have a follow-up Q&A session. And if possible, please help us turn on your video to make this event more engaged and human-centered. And during the presentation, please make sure that your microphone is muted all the time. And if you have any questions, please use the chat function to share your questions with us. We will address those questions during the Q&A session. And after presentation, please feel free to use the raise hand function to indicate that you want to ask questions in person. And I think that's all from me. Now I will stop sharing and handle the stage to Dr. Ragaert. Yeah, and it's all yours, Dr. Ragaert.
Thank you. Thank you, Dajun, for the very kind introduction. I will also share my screen now.
Okay, I guess he's just worried that it's not going to happen. So,
so can you see my presentation?
Yes, Dr. Ragaert. Yes.
All right. So, good day to all of you. I'm very pleased that I can give a presentation on the future of food packaging. Quite challenging to talk about such a topic in 30 minutes, but I will do my best to give you an overview of what is happening currently when we talk about food packaging. So as I already nicely introduced, so I work both at Gent University as Professor Food Packaging Technology and also on Pack4Food. And I have a few slides included to give you an idea about what Pack for Food actually is doing. So Pack for Food was founded in 2005, and it is an organization collecting, on the one hand, stakeholders involved in food packaging, so food companies, packaging producers, filling machine producers, retailers, and so on. And it's in fact connecting all these companies with research institutes working on food sciences, on packaging sciences, and so on. We do many things, as you can see, but most of all, we initiate and coordinate research projects which in fact have a common need in the food packaging industry. And you will see some of those projects popping up in this presentation. The companies where we are working with are both companies with a location in Belgium, but also abroad. So also some international companies as well. A nice combination of food packaging machines and so on. So here you see some examples of research partners where we frequently work together with. Also some network organizations, as you can see, for example, the Active and Intelligent Packaging Industry Association is a very nice network dealing with all types of smart packaging. So unfortunately, I have to start with this slide to talk about food packaging. As you're all aware of course, there is a huge problem in the environment with a lot of waste in, for example, the oceans. And a lot of them is plastic packaging waste. And this is something that we really should tackle. And I will also show you in this presentation different initiatives which are really there to decrease the huge amount of pollution of this kind. So this is, of course, a slide related with sustainability. Now, another slide, what I would like to show you is maybe this is not that well known, but we are in fact quite spoiled as a consumer. We can pick every day without taking into consideration the seasons or location. We can buy many things in supermarkets. An average supermarket has about 40,000 to 60,000 different items available. And for that, of course, you also need packaging to make it transportable. So this is really related with convenience. Now, the third series of pictures is related with the functionality of food packaging. And not many consumers are in fact aware of the functionality. Most of the consumers see packaging as waste, but in fact, it has functionality. I think most of you know that if you take into account fruits and vegetables, for example, 50% of fruits and vegetables are lost somewhere in the food chain. On average, if you take all the food into account, it's 30%. One of the things that can be done, or one of the things to reduce these food losses, is packaging. I don't want to say that we should pack everything and all types of food products, not at all. But at least we should dare to think, where can we achieve a reduction in food loss, for example, by using better packaging techniques. So in the end, if you want to summarize food packaging and if you want to summarize innovation in food packaging, it has to do with these three pillars. Functionality, so trying to select, to develop a packaging material that gives you the required shelf life in order to reduce food losses, a convenient packaging, but at the same time, a packaging which using the most sustainable packaging materials. This is a quite, maybe it looks quite easy and simple, but this is a very hard challenge for many companies to find a balance in between these three pillars. So what I would like to do now is to go through each of these pillars, and my main focus will be on sustainability, of course. But first I want to talk with, in fact, the most important function of food packaging, and that's functionality. So what are some trends in food industry in the last, let's say, 10-15 years? It has to do with, for example, mild preservation technology. So instead of sterilization processes to treat food products to give them a certain stability, often more and more pasteurization technology is used. So lower temperatures during food processing, also less use of additives, also a reduction in fat, sugar, and salt content. Now, many of these factors that you see here, they are in fact used previously to give a certain stability to food products. So if you decrease them, there you have, in fact, a problem in the stability of the food product. And one of the things that you can use then is, for example, food packaging. And I will give you later on an example on that. So what does that mean? Packaging should protect, for example, a lot of food products against oxygen, against water, against light. So this results in a lot of a large portfolio of available packaging materials. Mostly we have paper and cardboard available, we have glass, we have metal, and we have plastics. But in different cases, you can also have a combination of different materials. Think about drink carton packaging, which is often a combination of paperboard, aluminium, plastics. Or even within plastics, you can have a combination of different types of plastics, which is
hi, Dr. Ragaert, you are muted accidentally.
okay?
Yeah.
Is it okay now? Okay,
yeah,
sorry
okay
for that. Maybe I pushed some button wrong. So also within plastic layers, within plastic packaging, it can also consist of different layers. For example, a plastic milk bottle can consist a white layer, a black layer, and a white layer in the same bottle to protect milk against light. Now, what we also should ask ourselves is, there is a huge problem in the environment with plastic packaging. Why are we using plastic packaging? Well, to give you an idea on that, about 30 to 40% of all primary packaging, so that means packaging that comes into contact with food, about 30 to 40% is plastics. It has some reasons. First of all, you have a different range of available plastics. They are often very light, but at the same time very strong. You can very easily close them, and they also include some materials which protect the food against oxygen and water and so on. However, there are some important challenges. Waste treatment, I've already told you that, but also resources. Plastics nowadays are mostly made from crude oil, although we also see some trends in bio-based plastics, and I also will tackle that one in this presentation. Okay, one of the techniques so that can be used to compensate, for example, for reduction in additives is modified atmosphere packaging. This technique already exists from the 90s, but we see still an evolution in this technique. This technique, in fact, is mostly in combination with cold storage, with refrigeration. And here you see typical products that are packed under modified atmosphere. So what you basically do, take, for example, the cured meat products, so sliced cured meat products. When you buy them, not vacuum packed, but in a tray with a lidding film, the gas around it, the headspace, contains no oxygen. It contains 30% CO2 and about 70% nitrogen. And it's in fact the CO2, which is an antimicrobial gas, which is giving an extension shelf life. For example, if you would buy this product and freshly cut and then just wrapped in a piece of paper, you can maybe keep it for 5 days in your fridge. A modified atmosphere packaging gives you a shelf life of about 4 weeks, which is an enormous change, an enormous extension in shelf life. But of course, to be able to do that, you need to protect the food product in that sense that you need to exclude in that 4 weeks oxygen from entering and CO2 from escaping. So basically that means you need multi-layer packaging. And I just give you one example of a tray with a top foil with this composition. So you see, these are all plastic materials. PET, for example, you know, from plastic drink bottles. Polyethylene, for example, from deep freeze bags. So you see different layers attached to each other to give the required barrier properties. I think I don't have to tell you that these structures are extremely difficult to recycle. So you see here the balance between, on the one hand, giving enough shelf life to product, but on the other hand, How can we recycle these materials? And this is a trend also in packaging industry to in fact look for alternatives that give the same barrier properties. And I will give you an example later on. So this was about functionality. And the second function or the second pillar is convenience. I have only one slide because I really want to focus here on sustainability, but I give you one slide to give you some ideas. What is convenience? For example, e-commerce. So there are companies working on distribution systems. So this is in fact a box containing also cooling elements, and also containing, for example, a sensor, which is continuously communicating with the end consumer. What is the temperature? What is the relative humidity? And so on. The second example are these. It's in fact a barcode that you can paste on a package. And the moment you remove this green strip, this green label, you activate the barcode. And once the temperature exceeds 5 degrees, the barcode becomes black and becomes unreadable. So this is one of the systems called smart packaging to in fact monitor the temperature changes during transportation, for example. A third one, also very important, this also has to do with smart packaging, is this example here against, in fact, it's an anti-counterfeit technology. It uses the near field communication technology which is nowadays present in a lot of smartphones, for example. So it basically, within the cap of this bottle, there's a very small chip. The moment you make contact with your smartphone, you will access a website on your smartphone, and then the website will ask you to put a number that you find on the label. And then the database will check if this is an authentic bottle or not. This is a very important technology worldwide. It will become more and more available. Good. Now, sustainability, the third pillar. In fact, the first question, what is sustainability? I will just give you some words. And I think if I would ask to you, what do you think is sustainability? I would get different answers, which is good because sustainability is not one strategy that you should use, but different strategies. And most of the themes that you will find here, I will also tackle a little bit in this in the rest of this presentation. There has been a very nice publication in 2016 from the Ellen MacArthur Foundation, which was really looking to the most challenging issue being the plastics and how we can go to the plastics future. And there were 3 pillars defined. First of all, we should have more recycling. At this moment, if you look to the plastics recycling worldwide, only between 15 and 20% is effectively recycled. Secondly, we should reduce the leakage of plastics into the environment. And thirdly, we should decouple plastics from crude oil. So that means we should invest more in bio-based plastics. If I now take the example in Europe, then in 2018, there was a EU plastic strategy, which in fact has been inspired by this report from the Ellen MacArthur Foundation. From this moment, in fact, there has been huge KPIs on improving the economics and the quality of recycling, and also stimulating global action to, in fact, increase the sustainability of plastic packaging. An important aspect in Europe, it has a huge impact, in fact, is the so-called single-use plastic. So it's a legislation from 2019, which is now in most countries active as well, to reduce the marine litter. Basically what they have done is they made an inventory of the 10 most found objects on beaches in Europe. And some of them will be completely forbidden the coming years. For example, plastic straws will be completely forbidden in the whole of Europe. Also, for example, foam trays will also be completely forbidden. For other items you see here, you will not be able to give them free anymore, like, for example, drinking cups. And for other applications, like, for example, drink bottles, you will be obliged to include recycled content into bottles. More specifically, Within Europe, it is stated that by 2030, all plastic packaging should be recyclable or reusable. This is a huge ambition. And I must say that most of the companies, big brand owners as well, they have put already the date at 2025. Secondly, there should also be more recycling. By 2030, more than 50% of the plastic packaging waste should be recycled. And thirdly, by 2030, all plastic bottles should contain 30% recycled material, which is also a very huge ambition. So this is just to give you a little bit idea what's going on at this moment in Europe about sustainability measures. Now, within Flanders, who is a part of Belgium, we developed with our organization Pack for Food, together with other organizations which you see at the bottom of the slide, we created a roadmap food packaging of the future. With input from more than 60 representatives from companies, research institutes, federations, and governments, what should the food packaging of the future look like? And then you see that there are some measures to be taken with regard to sustainability. This you see here at the top. So it's about eco-design. I will talk a little bit later about eco-design. It's about improved packaging to give maybe a longer shelf life, do more sorting and more recycling of packaging. But at the bottom, you also see innovations that should happen within smart packaging, within artificial intelligence as well, and also create new business models, for examples, to include reusable packaging, or also with e-commerce, for example. Good. I would also like to give you 3 take-home messages when we talk about sustainable packaging. The first key message is, in fact, when we talk about sustainable packaging, you should always consider the product together with the package, because it's the combination of the two that you should evaluate. It's the package that is protecting the product. And in that sense, at this moment, we coordinate a project called CircoPack, which aims to develop a tool for companies to select the most sustainable packaging material for a certain food product. And that's really also a trend within food packaging. So-called life cycle analysis will become more and more important to evaluate which is the best material product combination. So you see the different partners who are involved in this project. And what you immediately see is that we really take into account also the shelf life of the food product, because it should not be the goal that you switch to a more sustainable material, but in the end you will reduce or you will increase more food loss. So shelf life evaluation should be part of that. Also sorting and recycling is evaluated in this project, and so on. And in the end, there is in fact a life cycle analysis methodology developed to compare different materials. Which type of materials? For example, for unpeeled potatoes, we are in fact investigating or comparing a paper bag with a plastic bag made from crude oil with a plastic bag made from sugarcane. And here you see some other packaging materials that are compared to each other. Okay. And we tackle, in fact, both short, medium, and long shelf life food products. So LCA methodology becomes more and more important also for food packaging. A second key message has to do with eco-design. Sorry, that was too fast. So that has to do with packaging optimization. I will show you here 5 strategies that you can use to make your packaging material more sustainable. So to, for example, remove certain packaging components you don't need, to reduce the thickness, to do more reusing, and so on. I will give you some examples here of things that we have done. For example, on reducing and recycling. There has been a project, it ended in 2019, and it was about finding optimal barriers against gas, light, and also migration. With migration, I mean transfer of components from packaging into food. And I will specifically give an example of gas barrier. So what we did in this project is I will show you the product. So this is the product. It's a ready-to-eat meal, and it's the reference package that was used by the company was this tray top foil combination. And we wanted to check if we, for example, reduce the complexity. Here you see only one type of material and only one layer. So this is much better recyclable. Can it still give the same shelf life? Or if we increase the complexity, can we increase the shelf life? So one of the things that we've done is we have monitored, the researchers at Gent University, they have monitored, for example, the oxygen concentration in the headspace of the package. This should be as low as possible during the storage, in this case of 2 weeks at 4 degrees. And then you see that, in fact, the reference packaging, the orange one, resulted in more oxygen coming in than the 2 others. And when we took a look to the shelf life determining factors, in this case, the lactic acid bacteria, then you see, because they are determining the shelf life, then you see, in fact, there was no change or no difference between the 3 different packaging materials. So in the end, it was concluded that instead of using the orange configuration, the yellow configuration can be used. You will have the same shelf life, and you will have a material which is better in recycling. Yeah. Another example I want to show you is reusing. Reusing becomes also more and more important. Also, we know already retailers who are really doing experiments to have more reusable packagings also in their ecosystem. Here in our region, we have started a project last month, and the idea is as follows. Imagine that the consumer brings back these type of packages to the supermarket, puts it in a collection machine. That machine is in fact screening this package with different types of cameras, hyperspectral cameras, other types of cameras, to check for scratches, to check for contamination, and so on. And then decides whether or not this package is no longer reusable, so it should be recycled, or it is reusable, but it should undergo a washing process so that it can be reused again for packing the new food products. Another important aspect within eco-design is try to use, where possible, bio-based resources. Could be fiber-based materials like cardboard or other types of fiber-based, but can also be bio-based plastics. So bio-based plastics, I will give you one or some examples. For example, this one already exists also more than 20 years, PLA, polylactic acid. This is a bio-based material, at this moment still mostly made from corn, and is also industrial compostable. Another example, and I have another slide on that later on, it's one of the polymers within the group of the polyhydroxyalkanoates. It's PHBV. It's these trays that you see here are PHBV trays. The resource is agricultural waste. That agricultural waste is fed into a fermentation installation where microorganisms are also inoculated on that, which are producing, in fact, some sort of, for them, it's an energy source, but it's in fact a plastic. And after extraction, you can make nice materials out of them, and those materials are also, by the way, home compostable. So very nice. And this material was developed in the framework of a European project. And then another type of bio-based materials, and this a little bit is confusing for consumers. It's a bio-based material, but it's not compostable anymore, because this is polyethylene made from sugarcane. And for example, Tetra Pak has on the market paperboard packages coated with bio-polyethylene. So 100% bio-based, but not compostable. So within the GLOPAC project, and this is also a trend in food packaging, try to use, where possible, side streams to make for example, packaging materials. And so this PHBV material has been used to pack fresh cheese, falafel, a vegetarian product, and also fresh meat. Together, two members of Pack for Food were also involved amongst Colruyt Group, a big retailer in Belgium. If you want more information, you have also the link there. The project recently finished. The last key message of today is we talk a lot about recycling, but before recycling, you should have a very good collection and sorting system. Yeah? With collection, that means that, and this is very urgent, we really need a worldwide approach, that every country really invests in collection systems, that a lot of packaging materials are collected and not ending up anymore in the environment. Also, the role of consumers there is very important. When we look to sorting, there is also a very nice technology coming up in the market soon, and it has to do with the integration of a unique code in packaging materials. And this is developed within the Holy Grail project. You also have here the website. If you see the amount of companies who are participating in this initiative, this is really a very important initiative to get, in fact, better sorting efficiencies. When all collected packaging come in the sorting company, then this technology makes it possible to really specifically sort different materials. How does it work? When we see this with the naked eye, then the camera in the sorting line sees this. So it's a digital watermarking technology. It's in fact some sort of barcode that you print on the packaging. And for every type of material, even for multi-layers, the slightest difference in a multi-layer composition will also result in another barcode. By doing that, you really separate all different types of materials. And separation, 100% separation, is needed if you want to have a very high quality of recycled content. This is here a food application, but here you also see, for example, a non-food application where you in fact have the same system. At this moment, this technology is now in a pilot phase, and I assume that within some years we will have it fully commercially available, which is really a very important milestone within sustainability of food packaging. Good. After collection and sorting, you have recycling. What do we see there? I will go immediately to the second point. Mechanical recycling is known already for many years. That's in fact where you shred the material, you remelt it or you repulp it, and then you make new packaging materials out of that. But as for plastic packaging, chemical recycling becomes a technology quite, in fact, mature to start to enter the market. With chemical recycling, I mean that, in fact, you break down the plastic back to oil. And from that oil, you make, again, new plastics. And that's basically the idea. There are different types of chemical recycling, but I will put it now within, let's say, easy explanation. So this is something which will really pop up to get more recycled content again into packaging. In fact, packaging waste should not exist anymore. All packaging waste should be used again to make new packaging. In that sense, there are three very nice initiatives going on, so you can check for each of them their website. For example, Circular Economy Flexibles, CFlex, is also a consortium of more than 150 companies who are at this moment working on design for recycling guidelines for both flexible paper, flexible plastics, and also combination with aluminium and so on. Forever Green is developing at this moment recycling guidelines for paper and cardboard. For example, how much plastic can be present on cardboard to make sure that you have enough functionality, but at the same time, you do not hamper the recycling. For example, in Belgium at this moment, the rule is if you have maximally 15% plastic on paperboard, you can put this composition into your paper bag. But for example, in Germany, for example, it's only 5% plastics allowed. So there is no harmonization yet, and this should change with this initiative. Okay, the last 2 minutes of my presentation, I would like to come back to our roadmap and maybe elaborate on the communication. And communication also means education. And I'm very proud to announce that at Gent University in September this year, we will have the first edition of our Advanced Master of Science in Sustainable Food Packaging. So it's a 1-year trajectory, but you can also combine it and with, for example, job activities, and you can also do it in 3 years. So we are in fact, what we want to do is in fact making or let's say prepare students to become experts in sustainable food packaging systems. So as you can also see from the curriculum, it's really focusing on food. It's focusing on packaging materials, on packaging economics, on shelf life, on food safety, end of life management, food packaging design, but also on, for example, sustainability, LCA. So it's really the, let's say, combining sustainability, food, and packaging. So if you want to have more information on that, you can also visit the website. There will be a lot of interaction also with companies, with guest lectures, company visits, also a master dissertation in a company, and so on. So this will start by September this year. So being said that, I would like to thank you for your attention. I'm showing you here the Pack for Food team. So we are a team of 6 people working on Pack for Food. And here on the right side, you have my contact details from Gent University. So feel free also later on to contact me by email or by LinkedIn or whatever to keep contact, or in case you have questions or an interesting project or whatsoever. I have seen here on my other screen that already some questions popped out in the chat, so I would be very happy to answer them. So I will now stop sharing my screen.
Thank you, Dr. Ragaert. It's a very informative presentation. I learned a lot from this like 35 minutes speak. And if it's okay with you, I will start with a question from the chat box. I think you can see from your view as well, but I will just speak it out so the audience can know it better. The first question is from Mike. And actually he was wondering, he has a specific question. So he's interested in the oxygen permeable plastic retail wrappers, for example, for the steak. Then the full case overwrap of the oxygen impermeable plastic for frozen shipping. So this case goes to the store with 50 individually packed frozen steak that look the gray color, I think. In the store, they are removed and thawed and then bloomed up red as they were fresh, ready to go on the shelf. So, and he asked what impact on shelf life. So I was wondering, maybe he mean the shelf life between the one oxygen permeable plastic with later wrapped on the shelf, and compared to the oxygen impermeable plastic for frozen shipping, and then change the package. I think that's what his question. Mike, if I misunderstand you, you can turn on your mic, turn on your speaker, and if you want to ask it more specifically. Then I think maybe I understand it right. You want to see the comparison between these two.
It's I would say quite challenging question to answer immediately, but maybe I will. I think by so you need in fact an oxygen impermeable plastic for frozen products for meat indeed, otherwise the color will change. Although yeah. And then of course the color comes back the moment that you that there is again oxygen entering. Yes, indeed. but your shelf life will be reduced because normally when you want to pack fresh meat in refrigeration, you want to give it a certain shelf life, you need also in fact modified atmosphere packaging. So basically what happens, that is in fact common practice in a lot of countries, is that fresh meat is in fact packed. So it could also be frozen before, but when it is thawed, it is packed in, for example, 70% oxygen and 30% CO2. And that effect also gives it a very nice red color. But at the same time, you will have a reduction in shelf life because, shelf life and oxygen is mostly not really compatible with each other. But that is something, it's also a debate. Why is it considered that the consumer really wants to have red meat? Why can it not be purple or even gray meat? Well, gray is maybe not recommendable, but purple meat, why not? Because if you want to have red meat, you need oxygen, and then you have a reduction in shelf life for sure. And this is a little bit the same here. The moment that you have the thawed meat and the oxygen comes into contact, you have the reds, but then the shelf life probably will be very short.
Yes, yeah. Thank you for the answer, Dr. Ragaert. And then second question is from the Francis. He said he would like to know the kind of material, for example, what kind of plastic that is suitable for sweet potato bread packaging.
The bread, that's a difficult one. On the one hand, you need to make sure, I assume you need to make sure that you get some water going out, because otherwise you will have molds growing into your bread. On the same time, if you lose too much water, your bread will become too hard. So that's a difficult one. Mostly it's some sort of wax that is used that results in some water transfer. If we look to a plastic that could do that, maybe polylactic acid. Maybe because polylactic acid has a quite high water permeability, so that maybe could work. Or starch. Yeah, starch. A starch film also has quite some high water permeability, but not too high. So yeah.
Okay, I think that's the interesting question. I don't see any sweet potato bread in the market yet, right? I'm not sure, maybe not in Canada, maybe in other countries there are some products out there, but right now I don't see anything in the market. So it's actually quite interesting. I don't see any like packaging. What is that like? So that would be a very interesting question. Thank you, Francis. And the third question from Harry is that, is it true some expired food between 1 to 2 months after expiration product can still be used depending on the preservation condition?
That depends on the type of shelf life, or sorry, on the type of shelf life date. So you have two shelf life dates. You have the use by dates and the best before date. The use by date, that's the most severe one. That is mostly for products that are microbiological unstable, where you can also have growth of, for example, food pathogens like Listeria. Typically, for example, for cooked meat products or for ready-to-eat meals. So there you cannot, in fact, you cannot consume the product after the use by date, just from a food safety point of view. The other one, the best before date, this is for products which in fact are microbiologically stable. Think about dry biscuits, for example, and there, or yogurt, also very nice example, or salami and so on, where the pH is quite low. there, in fact, like for example, myself also, I eat yogurt, which is sometimes more than 1 or 2 months after the date. It's still okay to consume it. Of course, the only thing that could change or could have changed is maybe the texture or the taste or the flavor, but it's perfectly safe to consume.
Okay, yeah, I think same for me. I also consume something after maybe expired date, but still, I think it's safe. But you can taste the difference there. And Harry has another question there. Is it advisable to microwave food products that are packaged in plastic rubber bags? I'm not sure if I understand him right. What's the plastic rubber bag?
Well, you have these type of rubbers that you can, for example, use for cakes to bake a cake or something. I'm not really in favor of that. Although of course, those materials can only come on the market if they have been tested thoroughly. Like for example, in Europe, you have to oblige a food contact legislation, and probably in other continents it's the same. So I assume they are food compliant and they are tested for these conditions. But in microwave, it depends on the structure or the composition of the food product. If there is a high amount, for example, of sugar and also some oil, then you can really have locally very hot spots, and there you can have migration. Yeah? So components from the package into the food. So, but I know, for example, for plastics, polypropylene trays are microwavable, are also tested for that. But yeah, is it advisable? Well, it's all, maybe in that case, it's better to have glass, because I did not talk a lot about glass, but glass is also a very nice packaging material. It's heavyweight, yes, but it is a very nice packaging material where you can do a lot of things with. Unfortunately, because of its weight, a lot of companies look for alternatives which weigh less, and then you come up with paper or plastics or metal. But why don't you use glass for this type of product? Yeah.
Okay, thank you for the answer. And we have one question from Ronald. He was wondering, what would be your opinion on the use of antimicrobial functionalized packaging with bio-based antifungal, antibacterial, or antiviral substances?
Very interesting question, because I also love, in fact, antimicrobial packaging as one of the active packages. You indeed also see a lot of research happening at this moment. The only problem or challenge, well, there are quite some challenges, but when you talk about food packaging, there are some hurdles. For example, what about the activity of these components against quite a large portfolio, because food is contaminated with quite some different microorganisms. If you want to functionalize the packaging, sometimes that's done during extrusion processes, which use quite a lot of heat. If you use components, antimicrobial components, which are heat sensitive, you have a problem. When you think about essential oils like rosemary or thyme or so, have also nice antimicrobial components, but at the same time they have some flavor, so that could also be an issue. And yeah, when you work with a coating, you also need direct food contact, and so many food products are not only contaminated at the surface, but also inside. And then it's also quite difficult to use antimicrobial packaging. So I really love the idea. It also, for example, chitosan, it's a very nice polymer with antimicrobial activity. But yeah, because of all those challenges, that's still the reason why at this moment there are almost no commercially available antimicrobial packages on the market. But I would say keep researching, keep investigating, because I really like the technology, but there are different hurdles to be taken.
Yes. Okay, and we have one more question from John. Is there any way BOPP metallized laminate can be recycled?
Yes, one of again very interesting. In one of my last slides, I've shown one of the initiatives on design for recycling guidelines was Recyclas. When you go to the website of Recyclas, I can recommend all of you to do that. Then you will see one of the pages on the website are the guidelines. And when you go then to the polypropylene guidelines, you will see that metallization is in the red or maybe in the orange zone, but for sure not in the green zone. So that means very difficult to recycle. So metallization is something you really need it for the shelf life, but quite some research is done to have an alternative. So instead of metallization, use another type of barrier coating, which is more compatible with existing recycling processes. So at this moment, metallized packaging, recycling companies don't like that, to be honest. So there will be more and more alternatives coming on the market for that.
Okay, thank you. And we actually have, I think we have enough, maybe 2 more minutes for the last question. Let's see, one from the Beatrice, or sorry if I pronounce your name wrong. Please, I would like to know your opinion on storing palm oil packaged in HDPE jerry cans, stored outside in the open sun. Is it bad or? I think
if I see open sun and food packaging, then well, I don't know the oxygen sensitiveness of palm oil, but probably quite sensitive to oxygen, I assume. HDPE is a material which is not protecting against oxygen ingress, depending, of course, on the thickness of the jerry can. But HDPE has a disadvantage that it has no oxygen barrier properties. So quite some oxygen will enter. Now, stored outside in the open sun, it depends also if your HDPE is transparent or not. If it's like the milk bottle, a white, black, white composition, then maybe it should already be fine. But then you also have the temperature is also an issue. So the oxygen permeability, so the amount of oxygen that is entering through a packaging material, is depending on the temperature. And it's quite a simple rule. If you increase, because it's following an Arrhenius equation, so very simple, if you increase the storage temperature at 10 degrees, you double the permeability. So that is some, and then even more oxygen will enter. So I foresee some problems, I think.
Okay, and we do have one last question. Is that okay with you, Dr. Roger?
Yes.
It's a quite a long question, so if he wants more detailed, he can contact you later as well. So this is actually from Bill, and he said, in the example you provided of the simplified recyclable PET to PET tray plus film packaging, was no additional polymer sealant layer required to facilitate the tray to film seal, if that composition proven just as effective as prolonging shelf life as a multi-layer polymer formulations? What obstacles exist to implementing such a simple and sustainable packaging formulation at scale?
Yes, and a very good comment. In fact, we see more and more PET packaging coming on the market for these type of applications. There is, however, a big but, and that's that this was only a shelf life of 2 weeks. If you want to have a shelf life of 4 weeks or even longer, then you need to have some barrier material inside the PET, but also there more recyclable alternatives exist. For example, PET, COX PET, so a silicium oxide coating, is a coating of only 1.0 micrometer. a very thin coating, but very effectively to reduce the oxygen permeability. So we will see this PET combinations more and more on the market, also because PET is also very easy to recycle. And for example, as well, like in European legislation, you can use recycled PET for direct food contact applications. So also there you have an advantage when you are using PET instead of other materials. So we will see this one more and more coming, for sure. Yeah.
Okay. Thank you so much, Dr. Ragaert. I think that's all the questions we have today. And thank you for your time for answering all the questions. And for the audience, if you have more questions and if you are very interested in this area, you can always email Dr. Ragaert, right? I think I leave the email address in the chat box. So if you want a detailed discussion, maybe you can contact Dr. Ragaert later. Okay, thank you. And Dajun, you can take over the floor. And
Yeah.
Thank you.
I think we're having some really tough but interesting questions. So we really appreciate your participations and those wonderful questions. And thank you, Dr. Ragaert, for the fantastic talk and all those answers. And please stay with us for a few more minutes because we still have some announcement about the annual meeting to make, and it won't take long. And before that, we still want to thank our AOCS membership director, Janet, and the program managers, Victoria and Bill, for assisting the organization of this event. And then we want to thank SCIG Chair AJ for leading us on the organization, this event. And then Daniel and Ivana for contacting the speaker and making this event happen. And we also want to say thank you to all the members in the SCIG leadership team. And then I think I will give it to Bill. Bill, do you want to take over and talk about the important announcement?
Hi, everyone. I'm Bill Stanton. I'm the manager of member communities and engagement with AOCS. Thanks, everyone, for coming. I'm not going to go through every single one of these, but mainly this is just a reminder that to register for the annual meeting and expo in May. We'd love to have all you guys there. We have some pretty cool things, including a new early career inspiration lounge specifically for students and early career professionals. There's also a ton of networking events, speed networking, division networking events. So it's a great place to, meet people, get some mentorship going, possibly even, and just make connections for your future and your future career. So please join us. I put the link to register in the chat box, but if you have any questions, feel free to email me. I'll put that in the chat box as well. And again, thanks everyone for coming, and thanks everyone that helped plan this.
I think that closed our event today, and thank you all for your participation again. And I hope you enjoyed today's event. Yeah.
Thank you all. Thank you, Dr. Ragaert.
Yeah, thank you, Dr. Ragaert.
Thank you all. Bye-bye.
Thank you.
Thanks, everyone.
Bye-bye.